Our ENE E499L project, what it does is it's autonomously mapping hallways. So the way it works is that using, if you want to bring the camera over, using the Kinect depth sensor, it figures out how far away the walls and the floor is and uses that data in correlation with this gyroscope on here, which figures out the orientation that the bot is facing, to map. To make a virtual three-dimensional map in this program called Unity that a user can interact with and go through to understand what a building looks like without ever having to go in themselves. So it uses these ping sensors on the side and in the front to go through the hallway without crashing into walls. It's a collision avoidance algorithm to figure out which path to take, and that's basically it. So right now I'm gonna run it, and initially what I need to do is allow the gyroscope to calibrate to the correct orientation, and then once that happens I will turn on the power to the Arduino so it can go forward. So currently it's calibrating, as you can see here. It's figured to 0, and then once it figures that out, it's going to start actually making a depth map. So it takes a little moment for it to figure out everything, and as you can see now it's come up with a solid number. So it's creating a map in Unity, as you can see right here, as it goes forward. And I'm going to turn on this so it moves forward and continuously navigates. If you want to zoom out, you can see the bot itself moving. Right? So it's using the ping sensors to understand the environment that it's in, and it's moving forward slowly, and it's mapping the hallway that is surrounding it. So as you can see, it figured out that it needed to make a turn, and now it's going down the hallway the correct way. While it's still properly mapping. So I just paused the code so you can get a look at what it sees. As you can see here, it created a map of it moving forward. And then as we scroll through this, it's a bit pixelated and blocky, but you get a nice understanding of what the hallways look like relative to the bot. So here, there's a bit of a weird number of blocks over here out in the distance. That's because of when it was making the turn, it saw blocks that, or it didn't understand what it was seeing, so it thought blocks were farther away than they actually were. But you still get the primary idea that there was a turn here, and that this is what the floor looks like, and this is what the sides of the hallway look like. So.
We also knew that for every turn the bot was making, we would have some jumbled data. So for every straight line that it was moving in, it mapped it perfectly. As you can see at certain points in which it was turning, we had jumbled up data, and that was what we expected.
Go.
So after the robot has mapped all the data, it stores it internally into a text file called map data. In order to transmit our information wirelessly, I wrote a program that acts as a server and client. The client, it resides in a separate system. We connect to it based on the IP of the server machine, and it waits for the host, for the client to connect. The client connects to it, and puts in. So on the client side, we're going to request map.data.txt. It's going to connect to the server. It's going to run a simple authentication to make sure that no information was corrupted during the process. It'll verify the checksum that I created, and the file should be transmitted successfully. On the client side, if I go to the folder where the directory where my client resides, I will see that map data has now been successfully transferred from the server side to the client side. So when we open up map data, we're going to see a bunch of gibberish because this is
so the Unity stores the data in vector threes, which is a Unity specific file type or data type. So when it's stored into a text file, it's complete gibberish. But but Unity can write this and read it properly and recreate this map through this what looks to be gibberish.